The outdoor BIX external cross-connect system has been designed to facilitate the management of main and distribution cable pairs at the primary cross-connection point. Developed at the Bell Northern Research Laboratories for Northern Telecom, the outdoor BIX system has been designed to improve the reliability of the local line network. All cable pairs are terminated on connectors, and flexibility is achieved by jumpering. Any E pair may be cross-connected to any D pair. In this way, housekeeping is improved, testing simplified, and maintenance problems reduced. The outdoor BIX external cross-connect system includes a new cabinet with a capacity of up to 2,000 total pairs, 1,000 E pairs and 1,000 D pairs. Mounting kits are also available for terminating outdoor BIX in any of the existing standard BT cabinets. We will now go through an installation sequence using the new outdoor BIX external cross-connect system. The cabinet is installed as an empty shell to facilitate the placing of cables. Once the cables have been placed in the ducts, sufficient slack must be left for terminating. This is approximately equal to twice the height of the cabinet. Having placed the cables, the mounting columns may be installed in the cabinet. These are a sheet metal assembly with the front panel hinged on the right-hand side. They are used for holding the connectors and distributing the individual binder groups. There are two sizes of columns, 400 pairs and 500 pairs. The use of the 400 pair columns allows 1,600 total pairs to be terminated in a cabinet, and the 500 pair columns allow 2,000 total pairs to be terminated. The first column, placed on the left-hand side of the cabinet, is equipped with a wire spool holder. Subsequent columns are equipped with distribution rings. To install the columns, open the front panel and place the keyhole slots over the bolts on the horizontal mounting bars at the back of the cabinet. The columns being used in this sequence terminate 400 pairs each. Tighten the bolts on all columns. The cable sheaths are removed to a point approximately 1 inch above the cable tie bar. The ends of the individual binder groups should be secured to prevent split pairs. Bond all metallic sheaths to the bond bars. The individual cables are then tied with plastic tie wraps to the horizontal tie bar. The binder groups are tagged for identification and then placed through the specified entrance hole on the hinged front panel of the mounting column. Exchange pairs 1 to 25 are placed in the top entrance hole of the left-hand column. The count is always from top to bottom and left to right. The columns are normally split so that the top half terminates exchange pairs and the bottom half terminates distribution pairs. Therefore, distribution pairs 1 to 25 will be located midway on the first column. Once all the binder groups have been routed, the hinged front panel can be closed and secured. At this point, we are ready to start the termination of the cable pairs. The sequence for terminating is to start at the top of the column and work your way down. In order to facilitate wire handling, a terminating fixture is used to hold the connector. It automatically builds in 4 inches of slack in each binder group and permits terminating with a tight wire. For convenience, the fixture is latched to the mounting column in the position below that of the binder group being terminated. The outdoor BIX connector is a 25 pair assembly intended for use with 0.4 to 0.63 mm plastic insulated wire and cable normally used in external plant. The connectors are symmetrical and contain insulation displacing contacts that do not require the prior removal of the insulation. Cable pairs are terminated on one side and cross-connect or jumper pairs on the other. It is colour-coded yellow to identify it as having been filled with a hydrophobic sealant to environmentally protect it for outdoor use. The connector is snapped into the head of the fixture and is ready for terminating. Holding the binder group in one hand, the pairs are randomly selected and fanned into the wire slots of the connector. The colour bar on the fixture and the black lines on the edge of the connector are to assist in pair identification. All pairs in the binder group must pass between the two larger posts on the fixture and individually between the smaller guideposts on the front of the fixture. The pairs are always under tension while fanning, and the thumb of the hand holding the binder group is used to route the pair between the small guideposts. The pair splitters, which are the small protrusions on the edge of the connector, are used to assist in the splitting of the pairs. The A lead is on the left and the B lead is on the right. Since strain relief has been designed into each individual wire slot, the pairs need only to be pulled straight down and they will not fall out. Once all the pairs have been fanned, the colour sequence can easily be checked against the colour bar. The BIX connection tool is used to individually insert the wires into the IDC clips and cut off the excess wire. To identify the cut side of the tool head, the cut-off mechanism has been coloured black. In this case, it should be pointing down. Insert the tool into the connector using the index finger of the free hand as a guide. Hold the tool as you would a screwdriver or wood chisel. It is important to hold the tool at right angles to and level with the connector. Now, push the tool fully forward to insert the wire into the contact. The wire will not be properly inserted unless the tool is pushed fully forward and bottomed. The click made by the tool does not necessarily indicate that the wire has been properly inserted. Once the tool has been bottomed, release the forward pressure and the excess wire will be automatically cut off. Continue across the connector to terminate and cut off all 25 pairs. To hold the connector in the mounting column and provide additional environmental protection, a retainer is used. Green for exchange pairs and blue for distribution pairs. Hold the retainer with the cover down and place it on the connector. Push it firmly forward. Use both hands to squeeze the retainer and the fixture. This will lock the retainer onto the connector and extrude the hydrophobic sealant in the retainer around the cable connection. The head of the fixture is then released and rotated 90 degrees. At the same time as the head is being rotated, dress the binder groups up and release the pairs from the small guideposts. Secure the binder group to the strain relief channel of the retainer using a 5.5 or 7-inch cable tie. Pull it up snug with pliers and cut off the excess end. Push the retainer release latch and remove the assembly from the fixture. Continue the rotation of the assembly. Snap the retainer cover closed and dress the wires. Snap the retainer into the column using your index fingers to ease the release latches on the ends of the retainer into place. Release the fixture from the column and place it in the next lower position. Continue terminating until all pairs have been terminated in the cabinet. Once terminating is completed, all pairs are designated. Pre-printed plastic designation labels are removed from the card and snapped into the pocket on the front of the retainer. Two sets of labels are provided, one for exchange pairs and one for distribution pairs. For convenience of jumpering, a spool of 0.5mm cross-connect wire is mounted on the wire spool holder of the first column. To run a jumper, lift the cover of the first retainer and insert the wire in the connector using the pair splitter to separate the A and B leads, A on the left, B on the right. Since the strain relief in the wire slots of the connector holds the wire, it can be pulled taut and routed through the retainer fanning strip. Note, the jumpers are always run to the right-hand side of the retainer only. It is then routed through the vertical and possibly the horizontal jumper channels and through the fanning strip of the second retainer. Lift the cover. Holding approximately 3 inches of slack in the palm of the hand, the wire is inserted in the connector. Use the black dots on the edge of the connector to locate the correct pair position. Terminate both ends of the jumper using the same tool that was used for terminating the cable pairs. Dress the slack into the vertical jumper channel and close the covers. Approximately 3 inches of slack should always be left on the jumpers to facilitate tracing of circuits and testing when required. Using the cable pair assignment list, all the working circuits in the cabinet can be cross-connected. To remove a jumper, open the retainer cover. Remove the jumper from the fanning strip and pull it straight out of the wire slots of the connector. In some instances, a pair of long-nose pliers may also be used to grip the short end of the jumper and pull it out of the wire slot. Jumpering for shared service can also be easily achieved with the outdoor BIX. That is, one E pair can be jumpered to 2 D pairs. Start by running the jumper from one of the D pairs to the E pair. Now insert the jumper in the wire slots of the E pair, leaving the 3 inches of slack as normal. Rotate the cutting mechanism lockout button on the handle of the connection tool 90 degrees. This will allow you to terminate the wire and not cut it off. Punch down the jumper, route it through the fanning strip and dress the slack into the vertical channel. Loop the other end of the jumper over the top of the connector and close the cover. Route it through the fanning strip and onto the second D pair. Reactivate the cutting mechanism and terminate both of the D pairs. To run a temporary bridge or effect a line transfer, the process is exactly the same as for shared service jumpering. In this case, just make sure that the temporary D pair, or the pair being transferred, is the last pair to be terminated. To access a single pair at any time to determine line status, or to listen for a tone, a single pair test probe is available. To use the probe, lift the cover of the retainer and place the probe over the pair splitter of the pair you wish to access. The probe is color-coded so that the test leads can be identified as either A or B. The crocodile clips can be attached to a test set or tone generator. Metallic access to the connection is also available through the metal contacts on the top and bottom of the probe. To isolate a fault when testing, simply remove the jumper. Use the probe to determine which direction the fault lies and then replace the jumper. Move the jumper forward about 1/4 inch each time you reconnect it. Remove any small ends of wire cutoff from the connector. To remove the test probe, use a rocking action, either up or down, to release it from the connector. To access all 25 pairs of a connector at one time, a test connector is available. To use the test connector, lift the cover of the retainer, line the ends of the test connector up with the ends of the retainer and push it forward, at the same time depressing the spring latches on the ends of the connector. When in place, metallic access is available to all 50 connections. The top row of contacts are the A leads and the bottom row are the B leads. To remove the test connector, depress the spring latches on the ends and pull off. Always close the cover of the retainer when you have completed your work. Also available is a test shoe. It is similar to the test connector, except that it is equipped with a cable and connector intended for use with automatic pair identification test sets. It is attached to the outdoor BIX connector in exactly the same way as the test connector. If for any reason you should have to replace a connector or retainer, your customers will never know. Replacement of these key parts can easily be done without disruption of service.
Hi. How are you?
Since slack has been built into both the jumpers and cable pairs, the retainer can be released from the column by depressing the small latches on the ends and pulling the assembly forward. Remove the jumpers from the fanning strip. Cut and remove the cable tie. Using a screwdriver, release the locking latches of the retainer and remove the retainer from the connector. At this point, a new retainer could be put back on and the process reversed. However, to illustrate the replacement of a connector, we would place the terminating fixture onto the column. Rotate the head upwards and insert a new connector. Place the old connector alongside the new one with the cable pairs across the top of the new connector. Fan the cable pairs into the wire slots of the new connector. Keep the two connectors as close together as possible. Select the no cut position on the connection tool and punch down the cable pairs on the new connector, but do not cut them off. Remove both connectors from the fixture. Fan the jumper pairs into the wire slots of the new connector. Now select the cut position on the connection tool and using the fixture to steady the two connectors, terminate and cut off the jumpers on the new connector. At this point, all circuits have been transferred to the new connector. Rotate the two connectors and re-terminate the cable pairs, this time cutting them off. The transfer has now been completed and the old connector can be discarded. A new retainer is then installed, the jumpers replaced, a new cable tie installed, and the assembly is placed back onto the mounting column. Replace the original designation.
Thank you for ringing. Goodbye.
Outdoor BIX has been designed with the telephone engineer in mind, simplifying work operations at the cross-connect cabinet. As indicated earlier, retrofit kits and instructions are available for all of the existing standard British Telecom cabinets. To install outdoor BIX in a number 3 cabinet, for example, remove the centre bar. Remove the existing horizontal mounting bars. Install the new outdoor BIX mounting bars. The one with the short lugs is installed at the top of the cabinet and the one with the longer lugs at the bottom. They are fitted between the cast lugs and the bolts are placed through the U-slots of the rear lug. One of the original mounting bars is reinstalled on the bottom lugs of the cabinet to act as a cable tie bar. Install the outdoor BIX columns and proceed to terminate and cross-connect the cabinet as previously described. The outdoor BIX system has been designed to not only simplify work operations, but to improve reliability and reduce faults and maintenance costs.